like. But okay, 869 reordered power of 2. Starting with positive integer n, we reordered the digits in any order, including the original order, such that the leading digit is not 0. Return true if and only if we can do this in a way such that the resulting number is a power of 2. Okay. Yeah, no, I'll definitely answer it. Answer anything, but let me quickly look at, So, so how long is this digit? It's 10 to 9. I mean, this is pretty okay. I think the thing to notice here is that for any number, let's say the number has x digits, there are only like 3 or 4 possible power of 2s, right? In that digit. For example, like let's say the 2 digits, then you have 16, 32, 64, and that's it. Because after 3 iterations, you multiply whatever it is by 8, and that is, I mean, it's less than 10, so maybe there's one where there's 4, but there's at least 3 numbers that, or at most between 3 or 4 numbers that are power of 2 of that number of digits, right? So then with that in mind, we can brute force to check whether you could reorder this number, whatever the input is, to one of the 3 numbers. I think that's roughly right? So okay, and that's just kind of like an upper bound you want. I think if you're lazier, or not lazier, but like if you were, like you could even do something more brute forcey given that premise by noting that I mean the only 32 power of 2s in int, which is less than a billion, right? So you could even just do it that way: 32 times some kind of like DFS, which is, let's say, O of n squared stuff. So 32 times some n squared, where n is not this n is the number of digits. So that would be log of this n. I'm doing a lot of math, or I'm throwing a lot of language out. Sorry about that. But what I'm saying is that like you could do some like basic stuff and it'll be mostly okay. But let me try using another language. I've been using C++. I don't know if anyone have any requests, but okay. Actually, maybe I'll just do C++. I've been doing C++ anyway. Cool. Yeah, so I'm gonna just do the lazy way. Okay. I guess 1 is about to, okay. Maybe that. If possible, I am return true. So I think this is what I would call it, like, yeah. I mean, this is kind of what I would say is like you don't have to prove it, but you know that n is going to be less than 32. I think the only thing that may be a little tricky, and it's not actually the case here, because once you kind of give it some thought, but the only thing that you may worry about is that maybe this overflows, but 10 to the 9 is a billion, so you know that for some number less than a billion, which is, I guess, 2 to the 29 for something like that, but even if your number is a billion at I, it'll only go up to 2 billion, which is still less than 2 to the 31. So that's why it'll fit. But I think that like overflow is the legitimate thing if this was just like off by a little bit. So in problems like this, so that's what I would worry about. Cool. And this is just an array of the 10 digits. Yeah. Such that the leading digit is not 0, but that's okay. Okay. Make sure. I think C++ actually initialized things to 0, but I feel like I've been bitten by random languages, so I just want to double check. What am I doing now? I think I was talking too much and not paying attention. But okay. Oh, I guess this isn't bool. Well, no eyes. Something like that would create the digits and then. Maybe something like that. Hopefully something like that. Okay, well it works for one, which is a good start. Let me try the other ones that at least they give you ooh, 64 as well. Okay. Why is 64? Well, I put force. Okay. Maybe that's an off by one. See, I'm still using C stuff here, so I should get better at C++ stuff. Oh, I see. See, good thing is catching. But yeah, okay. So I guess I did this thing, which is okay, which is not necessarily true because in this case it doesn't go to 64 to check. So maybe I'll just do something hard coded. Something like that, maybe. Maybe this may be dirty ones. I'll have to double check. No, it should be dirty. They should be fine. Okay, maybe I was wrong. Okay. Okay, so that solves that. Okay, let me try to. Where's my calculator? Yeah, hopefully. Don't jinx me. I'm just got my calculator up to put up 2 to the 2 to the 30 is already over 1 billion. Okay, 2 to the 29. I guess I said that, but this is 2 to the 29, and then maybe a similar one, but 2 numbers or a couple of numbers transposed. Okay, I think this is right. I can never tell how to eyeball it really well, but YOLO. Unless this is one of those things where it has a negative number and I forgot to take account into it. Okay. But sometimes they just try to trick you with like weird edge cases, and I'm unhappy about that because I always feel fooled. Okay, cool. So let's go into this a little bit. I think this is yeah, I mean, this is definitely a problem-solving problem, quote unquote, in that, like, obviously, once you know the algorithm, the coding is very standard. I think I could probably have, like, made this, I can have dry myself, if you will, on these 2 while loops. I could clean that up a little bit if I were had more time, or I don't actually remember how much time I spent, but this was a straightforward one. Once you kind of know you could do a brute force, I think the tricky one with this problem is that you might not know how to prove that you could brute force, but we kind of did it here a little bit. If I'm hand waved a little bit, definitely ask questions about this. But otherwise, it seems like a pretty straightforward one. It's just and this algorithm, in case you don't know, it's just like it takes the last digits and then just count how many of a given digit for a number, both in the input and then the number that we're checking against. And we know that this loop runs about 29 or 30 times, something like that, but fit for all the numbers. So you're literally checking all possible power of 2. So I think in a weird way, some of this is like it just tests you whether you're familiar with the numbers and so forth, like how to analyze powers of 2s maybe, or it's how fast it grows, right? Because this is like a 30 iteration loop on here, and this is just 10 digits at most, give it think 10 digits or 9 digits or whatever. So this one's really fast. In terms of an interviewee, I mean, I think it's okay. I don't know. I think this is one of those tricky ones where some days I will have a bad day and it'll take me like an hour. Some good days, like right now, you get to see the good Larry and myself in a couple of minutes because I just missed something like dumb and obvious. But in terms of coding, there's not that much to code. As an interview, whoopsie. As an interview question, I don't know. I think this is a cute problem, but it's still probably a little bit too straightforward in the sense that I mean I don't even necessarily call it easy, but it's almost like knowing a little bit of trivia. And if I ask someone this and someone gets stuck, the question I would ask myself as an interviewer is how can I unblock this person in a way that unblocks them incrementally and not like just give them the answer. And I don't at least immediately know how I would like because it's very binary, if you want to excuse the pun, where like like I hate those problems where there's like a switch where like okay I don't know what I'm going, and then you know this one thing and then suddenly you know how to solve it, right? I mean that's going to come in varying degrees, but in a problem like this it doesn't tell me anything about the candidate as an interviewer, and when a candidate struggle on this problem, I don't know how much I'm learning from it. There's not like, oh, let's try different things. And because what they're going to write, I imagine is just like different variations on different for loops. So I don't necessarily even learn how, like how the coding style or various different dimensions you could dissect someone's code. Because what it seems like to me, anything they're going to write is going to be like variation on like 20 lines of code, even as inefficient as hell or whatever. So that's why for me this would not be a great interview problem. But I think it's cute. It's interesting as a brain teasing problem. It's fun. It's something that yeah. I mean, it's cute. I enjoyed it. I think that's yeah. And yeah, if y'all have any questions, definitely let me know. And also, if y'all have another medium/hard problem, definitely ping it out in the chat, and I'll get to it next. I definitely do take requests. I think that's all I have to say about this problem. I don't know. I mean, because this is still like in terms of, I think that's what I don't like about these problems is that like once you know the quote unquote the trick, like this, I don't know how much more I could go into analyzing it. I think a lot of it is just knowing that, if it fits an int, which 10 to the 9 does, then you're just going to, there's only 29 possibilities, and then you could test all of them in very brute force way. And I think, if anything, this is a way more Leetcode-y typical problem in the sense that like you only know how to solve this problem if they give you the exact constraints, because like for harder problems you can imagine that you don't know if you can solve them, right? But I think actually, as I was saying in the beginning, before I kind of got a little bit brute force because I figured it'd still be fast enough. I think you could do some math around, like I was saying, like there are only 2 or 3 power of 2s within the same number of digits, right? So that solves things down a bit. So if you have like 1,000 digits, then instead of doing a crazy while loop with big number or big integer, you could only check 2 or 3, and you could check that in linear time. So like it's actually pretty fast. But that's not this problem. So, and even then, I don't know how I feel about that problem. But that's another story. Maybe that'll be in a future problem that I didn't know about. All right, cool.